shout out to everybody, to people who comes very early. But unfortunately, I came late, so I don't know who came early or not. But I believe Blessing was here very early because she inboxed me. Blessing, I welcome you to the meet. Oh, Drake came early. Drake, I welcome you. Future, I welcome you. You're always early. Joshua, I welcome you. Edu Brazil, of course. You're always on time.
Thank you.
Okay, and every other person who was here on time, I welcome you again to the meet. So, normally before we start, we always love to have a recap of what we did previously. And I would love somebody from the team to please tell me what he or she learned from the last time, or just go take us through what you took home from our last meet or the meet before that, or any of our meets. Anybody, before you speak, you may want to raise your hand. You click on the raise hand icon and I will give you a chance to speak. So can anybody give us a walkthrough of what he or she has learned from our last meet? Anybody? I believe the last time we handled functions. Yeah, we did functions where we covered the scope of variables, and we covered variable modifiers, and then we moved into functions. And functions, we learn about we learn how to define a function. We were taught how to call function in two ways, by value and by reference. So since nobody can take us on a recap, I believe we all took something. And just to remind us again, our lessons are all available on our GitHub repository. So if you've not forked the repository, the link to it is in the group or in the announcement group. So you can go on to click on the link, fork the repository, and then the tags are available on the repository. You can go ahead and attempt it. And then you create a pull request so I can see it and review it. And apologies that I've not been able to review anybody's tags recently. That's because I've not really been able to be on the screen. Yeah, I'm taking the medication, so I'm taking some time off the screen. But I promise that this weekend I will do that. I will make sure I review everybody's tags and give you your feedback. So please, if you've not done your tags, please go on to Fork the repository and do your tags so we can see that you are also improving. Thank you for that. If you don't know how to fork the repository and clone it, you can always inbox me and I'll walk you down the process. Or you can ask for it in the random group, not in the main group, please. In the random group, and somebody will attend to you and walk you through. So again, I want to thank everybody for being out here today. So today we are going to be learning about pointers. Yes, pointers. And today I will not be the one to take the class. One of our own that I respect so much. Since I met her, man, she has been improving, not just in the theory aspect, but it makes me to wonder, how long has she been in the program? Yeah. So I want to introduce to the house someone we already know. She'll be the one to take us on pointers today, and I believe and I know that at the end of the session today, we are going to benefit a lot from her. We'll learn much more we thought we could from her because she's actually good. So I want to introduce to you Blessing Chukwuwike, one of our own from cohort 11. She has been here all through our community here. Blessing, please unmute your mic. Let's and speak to the house.
Thank you so much, David. Hi, everybody.
Thank you.
Hi.
Blessing.
Can you hear me?
Hi.
You're welcome.
Okay, thank you. Can you hear me now?
Yes, we can hear you.
Yeah. Very clear.
Hi, Blessing. I'm not sure we can hear you.
Okay, can you hear me now?
Okay, yes, I can hear you now.
Okay, sorry about that. My network has been funny all day too. I just pray it so that please allow me, Philip. shop today. Okay, hi everybody.
Hi, Blessing.
All right, you all know that mostly is that I can always get a rescue. All right, so I'll just go ahead and share my screen. But first of all, I want to be sure that everyone can hear me.
Yes, okay.
I can hear you, yes.
Okay. Okay, thank you. So I'll go ahead and share my screen, and I prepared a little presentation that will just to before we go into trying to solve anything, so that we can know the theoretical aspects before solving, or sorry, did I say solving? Before coding. So here we go. Can you all see my screen?
Yes, we can.
Yes.
Okay. So so we're going to be looking at pointers, and there are key areas we'll be discussing today, which are the syntax, the operation, then pointers to arrays, and then the usage. Okay. So first of all, what are pointers? Now, just like every other variable that we know, pointers are variables. But then I like to look at them like variables with superpowers, because they do what other variables would not be able to do, like being able to store address. Other variables cannot store address. So the pointer stores address. That is, it points you to an address, right? And then they're also used to access data that are stored in the memory address. We can also use them to manipulate data. Now, pointers can also be used to improve the performance of code, and there's just a lot more that pointers can do. When we looked at malloc, we also saw how pointers help you allocate memory for you to be able to work with, right? So pointers, like I said, I like to refer to them as variables with superpowers. All right, so let's go to the next slide. Now, first, we would like to look at the syntax of a pointer. Now, a pointer, in C language, the pointer syntax is the name of the pointer. But before the name of the pointer, you put an asterisk. So you must first define the type of the pointer. So, for example, if you want to point to an integer, your pointer has to be an integer. If you're pointing to a character, your pointer has to be a character. If you're pointing to a string, which is also a collection of characters, right? You also has to be a character. And then if it's pointing to an array, which is a collection of integers, it has to be an integer. Okay, so you first of all declare the type of the pointer, then you put an asterisk, and then the name of the pointer. Is everyone following me?
Yes, of course.
Okay, all right, thank you. So now for us to be able to access the memory address that the pointer is pointing to, that's to access the value. Now that is what we call dereferencing. For you to be able to access the value in the address that the pointer is pointing to, that's apart from when you're declaring your pointer, you also use the asterisk, and it will help you access that value or be able to manipulate the value that is in that address. Now, I have a little mental note I make to help me know when a pointer is dereferencing and when it's just a pointer. Now, I like to say, when you go to, many of us have visited places that, let's assume you go to a corporate office and you need to meet somebody in that office. Let's assume you're going to meet a doctor in the office or something. And then you get there, you ask for the person where his office is located, right? So when you get there, someone points you to the address. So that guy is pointing you. So that guy is like a pointer, pointing you to the address. That's to the particular office you get into to meet that person, right? But then when that guy now takes you by the hand and takes you into that office and introduces you to the person you came to see, right? You can see that person. Now, he's not just showing you the address, he's showing you the value in that, holds you by the hand and takes you into that office and say, look at Dr. so the person you're looking for, right? And taking you to go and meet that person you came to see. Do you understand? Is anyone getting my analogy?
We get it.
Yes, yes.
You get it.
So the because the guy is like your G, is your star. So whenever you see that star,
I am,
you just
yes.
say, this guy. When you see that star, you just say, Kai, this guy is my guy. He's taking me directly to the value, right? So that's that for the referencing. All right, so let's look at pointers operation. Sorry, I just want us to go through the whole notes before we begin to particularize some of these things. Now, pointers can be employed to complete various tasks like arithmetic, comparison, and a lot of other things, right? So it is a very powerful tool. And we're going to be running with some of the operations when we start working, right? Now, let me go to the next one. Okay. Now, pointer arithmetics. Now, there are certain arithmetic operations that you can run with a pointer, and there are certain that you cannot run with a pointer. For example, when you want to add a number to a pointer, that is allowed. You can add a number to a pointer, and that is what we call incrementing a pointer. And we can also subtract a number from a pointer, which is decrementing a pointer. Then there's a point where you can subtract a pointer from another pointer. When you do that, what you're trying to get is the address, the difference between the two addresses, right? So that is subtracting a pointer. And then there's also comparing pointers. But what you cannot do with your pointer is you cannot add two pointers. You cannot divide two pointers. You cannot multiply two pointers. So these three arithmetic operations cannot be done with a pointer. So let's take note of that. Now back to our this thing. Back to our PowerPoint. Okay, sorry, my system is hooking. Okay, then there's also pointers to array. I think we've given a little background of this. We know what arrays are already, right? A collection of integers, right? So when an array is created, right, a pointer is used to show us the beginning of that array, and then we can always increment. Now, there's something that pointers can do. Pointers can run through. That's when we increment them, right? They can iterate from one variable to the other. That's from one element of an array to another. So they can run through it using the pointer arithmetic for incrementing, right? Let's look at then the usage. So they're used in C, programming language, and they're useful for manipulating data. So those are basically the key things to note about pointers based on the areas we're covering for today. So let's go into let me stop sharing this and then take us to let's look at the pointers. First of all, we need to understand. I'm coming. Just give me a minute. I need to stop sharing and then go to our programming. Okay. Sorry, I was working earlier. Let me clear this. Can you see my screen now?
Yes.
Okay.
Yes.
So first of all, we need to understand the role of pointers, right? So we're going to start, for us to understand this pointer thing very well, we're going to start by doing this. Now, for you to be able to declare a pointer, there must first be a variable. Because what are you pointing to if you don't have a variable? you don't have a variable, you're not pointing to anything, I guess. So you have to have a variable. So let's assume we have a variable int a, right? And then this a is equal to 10. And then we want to have a pointer that is pointing to this a. So we declare a pointer. We spoke about declaring pointers. And when declaring a pointer, there must be the asterisk to show that it is a pointer that you're declaring. Okay? So now, because this pointer is pointing to the address of A, it is important that we use the sign for address, which is ampersand, right? So it is pointing to the variable A, which means the value in the variable that it is pointing to is 10. That means when we do that dereferencing I told you about, when we do that dereferencing, what the value we would be expecting to get would be 10. That means the guy we are going to see in that office is 10. But then the office itself is A, right? Okay, so let's look at this. For us to verify that what we're doing is correct, we have to print and see if it will truly show us if it will truly show us what we're claiming it will, right? So first of all, let's print the value of the value in A, right? So we're going to print the value in A. So let's print this and see. So the value of A is 10, right? Now, let's see if we can get this value of A using the pointer. Let's see if we can access it using the pointer. So let's see again. Now, this time around, we want to access A, but using that our G, that our star boy. So we're using asterisk pointer. Oh, sorry. Okay, so can you see that we've been able to access the A using our G? This guy took us straight to the value of A. Hello, can you hear me? Hello?
Yes, we can hear you.
As for me to be jumping, I can't hear it properly.
Okay, I think her network is paused, so let's just give her some time. Okay. I believe she'll be back online.
I think I'm back.
Okay, I'm back. Thank you.
But where did I get lost or whatever?
Okay, I think you left us immediately. You run the program. Okay, all right. Thank you. All right, so we can see that we've been able to access the value of A. That's the guy inside that office, right? We've been able to access the guy inside that office using this our G. So this our G took us directly to the guy, and that's what this asterisk does here. So we dereferenced here, and that is why we also got the value of A, right? So let's try something different now.
Now we want to look for the address of A, right? So for us to be able to find the address of A, remember that to access the address of A, we can use, that's the ampersand A, right? So we'll see that, how we can access that using that. And we'll also use a pointer to see how we can access that. So let's see, ampersand A for the address of A. Okay, let's see. Let's go back first. All right, so this time around, it shows us the address of A. On a normal day, the pointer shows you the address. That's when you don't put this asterisk. It shows you the address. So let's see if that would work here. Okay, so let me run this now and let's see. Now you can see that the address of A, when we use the ampersand A and when we used PTR, that's the pointer, you can see that it's the same, right? So that's basically what
I can't hear anything, Miriam. I'm sorry. I don't know whether it's my network or your network.
Okay, can you hear me now?
Yes, we can hear you now.
Okay.
Yeah, now.
All right.
Now.
Okay, all right. So let's try to dereference and see.
Is it your network or what?
Hello? Or can you hear me now?
Cutting,
Hello?
jumping.
I can hear you
I
now,
can't.
yes.
Okay. Seems like I'm going on and off.
Exactly.
We can hear you. It's just that when you type, it thinks you are still talking.
Oh, okay. 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 Sorry about that. It's a Nigerian thing. So let's run this and see. Oh, sorry.
Okay, so we can't hear you anymore. Okay, please, you'll bear with her. It's a network too. And all these things are certain that it will happen.
Listen, what is happening?
Technical issue. So let's just give her a minute.
Since she's using Glow.
Hold on, please. She'll be back online soon.
Hello, guys.
Don't worry, she'll be back online, please.
Can you hear me now? Sorry, I had
Yes,
to.
we can hear you now.
I had to switch to another network to see if it will be better.
You are using Glow,
Okay,
right?
thank you.
You are using Glow.
I'm not using Glo, I'm using
We shall
MTN.
concern you now.
I'm using Okay, so I saw some hands while this. Can't hear you.
I think we are going to have to get with that network.
I can hear you
Hello.
now. I don't know what's happening. Hello?
Okay. Hello. Can you hear me?
Hello? Yes, I can hear you now.
Hello. Good evening. Okay. Good evening.
evening.
I appreciate. Thank you very much for this. For the lecture that is actually going on now. I just wanted to chip in something I think for a better representation of the address, you use the P comma specifier instead of the. Thank you.
Oh yes, thank you. I didn't notice. I was just using percentage. Sorry. Thank you. Hello, can you hear me? Oh. Hello, can you hear me now?
Yes, we can hear.
Yes.
we can hear you.
Oh my
Yes, I
goodness.
can. I can hear you.
So sorry. Okay, so sorry. I somehow forgot that we're supposed to use the %P specifier. So when you're representing an address, it's always %P. It's when you're referring to the value inside the variable, that's when you use %D. Okay, so I saw some hands. I thought some people wanted to ask some questions. Hello? God, what is this?
You were down for a bit. Now we can hear you.
Is it that there's a special anointing for this thing to go off when someone is doing the presentation? Because I mean, it doesn't do this to me when I'm attending.
You can imagine now. See if you can climb and be able to.
I have changed positions like 3 times.
It's because you're the one presenting. That's why you're using more data.
Oh, okay.
You're presenting. That's why.
I didn't know that. Oh, I didn't know that.
You are flowing. You are flowing.
Hey, I didn't know.
Is this program like recorded? Maybe you can watch it later. Is it not recorded somewhere?
Okay. So, thank you so much, Dixon, for the observation, and I've been able to address that. You can see what Pascal is saying to me. Very unkind human.
Okay. Excuse me, Blessing.
Yes.
Okay. This page, it might not load now. So I would suggest that you highlight everything and copy it and then refresh the page.
Okay. I thought I had some hands up and I thought some people wanted to ask some questions.
We wanted to ask questions about your network. Well, no problem. Just change. Continue.
Okay, let me run it now and see. Oh, okay.
You didn't clear the other one.
Oh, wow.
Just highlight everything, clear everything off, and then you paste.
Okay.
You didn't clear what was there.
Yeah.
And then repaste again. Good.
Okay. All right. So you can see that we dereferenced what was in A. That's we dereferenced the value, and then with that, So even without touching the variable itself, we have been able to manipulate the value in the variable A by changing it to 6. And our output still gave us, it gave us 6, indicating that we have successfully changed the value. So that is one of the superpowers of pointers. Okay. So let me go back and okay, so let's do another example. I don't know, did we get this example? Is there any question about this one? Okay, Pascal is raising his hands. Pascal.
Okay. Blessing.
Yeah.
From my observation, I think the last one you did, if you compare the results you got from the output, you are having a negative for the pointer, for the pointers, and now it's changing. What could be the cause of that? Was it that the answers you were getting before was for the 10, integer 10, and now it's, I want to understand, because this one is different from the initial one we got.
Okay, now for that one, I used the wrong format specifier. That was why it gave me that figure, that value. And thank God Dixon observed, and he was able to call my attention to it. So when you're referring to an address, you use %P instead of %D. And your answer would come in a hexadecimal format, which is what we can see here. But because I used %D, which is for an integer, which is the format specifier for an integer, that was why we got that value. Okay. And yes, and another thing is addresses can change. Let me run it again and let's see. Let me run it again and let's see if it changes. Okay. You can see that it's changing. Can you see that?
Okay, that is clear now. I think it's the changes in the random changes.
Yes, it changes. But like I said, based on the first example, I used %D. That was why there was a problem with that was why we got -3 something. Yeah, so that's it. Any other? Okay, Aina Adewale is raising her hand. Please go ahead and speak.
Okay, good evening. I can't see your screen, and I've tried to rejoin about 2 times now, and I can't still see your screen.
Okay, can any of our tech brothers here help us? Because I don't know the possible reason.
Okay, I can see your screen. Perhaps it's from his own end.
Yeah, I think it's from the end. I think it's from the end. I can see her screen from here.
Okay, can anybody suggest what he can do to make it better?
I think you should
log out and come in again.
Go out and come back. That's what you should do. Go out and come back.
All right. Thank you so much for your suggestion.
Thank you.
I think someone else raised her hands just now, or his hands. Okay, yes. Bongu Musa, something like that. Sorry if I murder your name.
No, I wanted to give a suggestion on that screen. Maybe if you can try to zoom like in a bit.
Okay, my screen. Okay, to the person, right? Okay, I didn't quite get what he was saying. Okay, Mr. David, you were about to speak. Or David?
Okay, yes. I have a question.
Okay, sir.
But first, if he comes back, I would suggest that he should pin your presentation screen to his own screen so he can see it clearly. Okay? Can you hear me?
Can hear you. I think Blessing is
okay. Please just give her a minute and she'll be back. It's a network. I know how these things are.
Okay. We'll wait.
Yeah. Hi, Blessing. We're waiting for you. Okay, so while we wait for her, I will just say a few things. Okay, so I believe we are all getting the concept of pointers. Basically, oh, she left entirely. She will be back soon. So pointers are variables, but instead of a normal variable that stores values, this stores the address of a variable. So just like the way you could store a number, an alphabet, letters.
Okay, I'm back now.
Okay. Welcome back. We've been waiting for you.
Sorry, guys. I'm so sorry. I'm not a bad person, please.
It's okay.
Understand very well.
Okay, so let's look at the next example. Let me share my screen.
I haven't asked the question. I haven't asked my question.
Okay, all right, please.
Okay, so my question was, please share your screen so I can point at the question.
Okay.
Okay, so yes, I can see your screen now. So the question is, in using pointers, use it to store memory addresses, and at the same time you could access the value stored in that address. So may I ask, I could do the same thing using a normal variable to store a value. So why do I need to use pointer?
I didn't quite get that.
Okay,
I'll ask you to use it. Yeah.
So my question is, the pointers are used to store addresses, and at the same time, we could access the value stored in that address.
Yeah.
So why do I need to store the address of a value? Why do I need pointer in the first place?
Okay. So basically, there's so many reasons why pointers are important, right? Because one of the things they help you do is manage your memory, right? And then it's easier to, let's assume you want to use an array, right? Or let's say you do not have access to, you do not know the address. The pointer can easily take you there. Do you understand?
No.
I don't know if I'm clear with that. So the pointer can easily take you to the address you're looking for, and then it also helps with managing memory in the sense that, let's assume I have an array and I need to move to a certain maybe the third element or the fourth element. The pointer can just easily take me there and take me back. Was that clear, Mr. David?
Yes, but not very clear.
There's something you need to add, or if the yeah.
No. I would have loved to ask. Please, can you give me like a situation where I could apply pointer? Then in that case, I will be able to relate.
Okay. For example, let me use an array as an example, right? Is that okay?
Yes, it is. Okay, so I can't hear her again.
Hello.
It's network issues, please. You'll bear with her. She'll be back soon. So while she's coming back, I will still say what I wanted to say earlier. The pointers. Is she back?
Yeah, I am.
Okay.
You wanted to say something? I'm waiting.
No, we didn't hear you. So I was trying to address the team.
Okay. All right. So, like I explained earlier, you can use. I want to use this example, this question, to be able to show how we can use pointers to move from one element of the array to the other. Okay. Can you hear me?
Yes, I can hear you.
Can't hear again.
Hello.
Okay, I think she's still trying to type.
I'm back now. We can use pointers. That's in the case of an array. Okay. Now this example will both show us it will both show us some pointer arithmetics and all of that, right? I hope I'm still being heard.
Yes, we
can hear you.
Yes,
Are you there now?
Again, it's network issues. Like, I don't even know what I should do, or because she was supposed to take the class, but apologies for all of this. However it is, if we don't understand what is going on, we will still have this class again, and perhaps I will take it too. Yeah, please, I apologize for all of this. Hello, team, please.
We understand. It's a normal thing.
Understand is everywhere.
It's not your fault, Mr. David. So it's no problem. We understand the hitches in network sometimes.
Okay, thank you. I appreciate it.
Okay,
But
Mr.
she can
David.
still take a suggestion of what that person said. Just go outside, climb a tree or a mast or something. Maybe the network will be better.
Are you kidding me? Glam tree.
Okay. It's okay. It's okay.
It's
Okay. Okay, so
Say it right time.
Okay, Mr. David.
yes. Okay. So please, I'm having a low battery, and okay.
Yeah,
Dixon,
I
I'm
don't
not
know.
sure.
I was just trying to see if I could give a little answer to that.
Okay, please do, of
I
course.
said you asked a question.
Yes,
Okay,
please do.
let me just see if I can answer it, but I don't know if it's to the fullest, but at least a little. You said you could declare a variable and use a pointer to access the value stored in that memory location. Now, you said you could do that with a normal variable, but why is it that we need a pointer? I think we need a pointer to access we use pointers not because we just want to access the value in that location, but because using a pointer can help you dereference the value stored in that particular location. That is, when you use a normal variable to access the address of a variable, you are doing just something like a call by value. You're doing a call by value. That means you can only access, but you cannot change the value in that memory location. But when you're using a pointer, the pointer will assist you to put the variable into a global scope, thereby having access to reference that variable. You could modify whatever values in that variable. So using I think pointers actually they do more of call by reference, not call by value alone, or call by reference. Thank you.
Okay, that helped a lot. That was very, very clear, and I believe everybody got the answer to that. Thank you, Dixon. I appreciate that. Okay, so I think she's back now. Okay.
I'm back again.
Okay, please excuse me,
Yeah.
please. Okay,
Okay.
so I'm having a low battery, so I may go off like any minute from now. So the class is now in your hands. So after you give me a feedback on how things went, in case I leave.
Okay. Okay.
Okay. Hello. Sorry, apologies for actually chipping in. Sorry, I don't know if I'm audible. Can you guys hear me?
Very
Yes,
clear.
we can.
Yes.
Okay, great. So my name is Simon Jerry. Actually, this is my first time joining this meeting, and I believe this is like a group learning. Am I correct?
Yes.
Okay, so what I would suggest is, in case of maybe she goes off, she's actually doing a nice job, right? You are doing a job. I have to congratulate you for that. I'm blessing you. You are doing a great job. Well done and keep it up. Yes, in case she goes off, anyone in the room can actually continue. It doesn't have to be a presentation. It could be Eugene explanation, just like how Mr. Duke Saint Ehigbura just did. So I think it will be kind of helpful and it will keep the meeting or the group learning keep going. Yeah, thank you very much.
Okay, thank you so much. Yeah, thank you so much. Please, you guys should be able to. Thank you, Duxin. I came in when you were explaining why the pointer should be used, and that made a whole lot of sense. I remember when David was teaching us about functions in our previous class, and then he was talking about, we looked at a task where the first swap did not happen. It was a second swap because the referencing was done there. And then he explained how, the whole global variable and call by value, call by whatever, right? So that made a lot of sense. Thank you so much. I hope I'm still being heard.
Yes, of course.
Yes.
Okay.
Yes.
Okay. So I said we're going to look at an example where you can use pointers for arrays, right? So here's an example. We're going to run through it. So this is our array, and we have 5 elements in our array, and then we have to declare our pointer now. Our pointer PTR is equal to the array. Then we declare a variable n, which refers to the number of value in the number of elements, in the. So let's put it size of is the same thing like the number of elements in the array. Now, the number of array is the size of the entire array divided by any of the arrays. Okay, divided by the size of any of the arrays. So let me just use size 0, right? Size of size of 0. Then we're going to print I want to print the elements of the array, right? Now, for us to print the element of the array, we'll need to use a loop, a for loop. Let's use a for loop. So let's use a for loop to print that. Now, because we want to run through, right, we're going to have to use, we're going to have to iterate through it. So let's do this. Or I can declare the variable I in there, or I can do it up here. But I think let's just go ahead and do it inside. Int I is equal to 0. So when we're looking at the first element, which is 0, We're going to start with the first element, which is 0. And then we're going to iterate. And this is the condition. The condition would be that I is less than n. And n refers to the size of the variable, which is the number of elements in the variable. And then we're going to increment. Okay. Now, so let's print. Okay. I forgot to open my brace. Okay.
Hello, please. Are you using a semicolon or comma? Check, please.
Oh, sorry. It's supposed to be semicolon. It was a. Sorry, that skipped me. I thought I was using semicolon. Okay. Oh. Okay. Thank you so much for that. Where? Oh, thank you. Okay, thank you so much. So, I'm going to be printing now.
Printf and semicolon. The printf and semicolon.
I didn't get that.
I mean the printf and semicolon are the elements.
Thank you. And okay, I think I've corrected what you're saying. Okay, thank you so much. So, SND. Let's space it to make our work a bit more organized. So we're going to space it.
Hello, sorry to come in here. In line 9, the I should be assignment operator, not equality. Please, you can correct that.
Okay, yes. Thank you. I just realized I'm initializing. Right? Thank you. Did we get that? Do we understand why? Hello, everybody?
Yes.
Okay. Thank you. So the reason why we're using it is because we're initializing. I didn't take note of that. Thank you so much. All right, so we have, we're printing and we're dereferencing. Do we know why we're dereferencing here? Does anybody understand why we're dereferencing here?
I do. I don't know if any other person does.
Okay, please tell us why we're dereferencing.
Okay, because we are trying to print the value stored in our pointer.
Okay, yes.
Or in our address.
Yes, that's the reason why we're dereferencing. And then we spoke about pointer arithmetic, where we increment using pointer, right? So that is what's going on here, right under the printf, for that where we dereferenced. That is what is going on here. So it's incrementing the pointer. And then we want to take it to a new line. So we want to take it to a new line. So here we go, new line, right? And then we return. Let's return 0. Okay, so let's run it and see. Ooh. Okay, I didn't comment my. Okay, let's run. See, element. Oh, thank you. Okay, so here we didn't include our header. Okay.
Okay, I'm sorry. Yes, I will also suggest you also read the error. You can see you're having some issues. Yes, that one is one. On line 9 to line 9, I think you have a missing element there.
Yes, that's why when I read this thing, it takes me. You said line 9. I don't think there's an error in line 9.
Yes, actually, it was complaining about line 9, but I think you fixed that.
Yes, it was complaining about that because of an error that had happened in a different location.
Okay.
Sometimes an error happens in a different line, and then it affects the value or whatever is happening in another line. So that was exactly what happened there. So now we can run. Now our program just ran. Now let's explain the whole what is happening here, right? So we have an array that has 5 elements, which is 10, 20, 30, 40, 50. And then we declared a pointer. Now this pointer points to the address of the array, right? So the next element, the next variable we declared is n, which refers to the size of the array. Now that's the number of elements in the array, which is the size of array divided by any one of them, right? And that was, of course, that is 5. Okay. So first of all, we want to print the elements of the array, right? And to get the elements of the array, we need to run a loop to take each element of the array to print each of the elements, right? So we're using the I as the iterator. So when I is equal to 0, when it's 0, the first thing that happens is that it will check if it's less than n. And remember, n is 5, right? So if I is less than n, it would go ahead and print, right? The first element, which is 0. So it goes ahead to print it. Now, like he said earlier, this is the referencing. So it's giving us the value, not the address. So this will take us to the address. This prints out the element in it. Then, the same way we're incrementing the value, the same way we're incrementing our pointer. So it keeps going from 1. So when it becomes 1, it goes back. When it finishes with the first element, it now goes back. It becomes 1 this time around, and it runs again until it gets to 4, which is the last number less than 5. Once it's 5, it won't run again because 0 to 4 makes 5, right? So it won't run again once it's 5. So it has run from 0 up to 4, and then it has printed. So let's go 0, 1, 2, 3, 4, right? And then, of course, the new line that we printed. Is there any question about this example? Okay.
Yes.
Dixon?
Okay. I just want you to make us understand something. And my question is this. In the first example, when you were assigning an address or a location to your pointer, you used an ampersand sign. Pointer equals to an ampersand sign, then the variable name. So what is the difference between using the ampersand sign and using it for an array? Okay. Because now if you look at your initialization, you are not assigning there was no ampersand sign, so you can just explain to us why you skipped it.
Okay. Now this question he asked has been a question I've been asking. So why this? But then I realized that for every array and every string, the ampersand sign is not a part of it. And I drew a conclusion, which I am subject to being corrected. I drew a conclusion that because the array is not referring to one particular element, it's not one. For you to have an array, it's more than one element. So you cannot say the address of that one element. Now, in an array, the first element is always a pointer. So that is my conclusion. But Dixon, if you have any other, or if you have a different perspective to it, we would appreciate it.
Okay. Yeah. Sorry. Thank you very much. That explanation was interesting. But just to add to it, the name of an array. Remember, an array is a memory block.
Yes.
You are keeping a memory block and saying that for so size, I want to keep this block for so size of data. Now, the array name is it's acting like the address of that memory block, and and by default it has done the arithmetic calculation for that specified size you've created or you've assigned to it. So whenever you declare an array, the name of the array holds the address to that full array location. So that is the reason why you can use the name like yes as the address of that location. Now, since an array is not just an element, so it's not going to be pointing to just one element, rather to the block. And with your arithmetic array, your memory arithmetic, you can then get each value from that array or from that memory block. Thank you.
Thank you so much. Thank you so much. Yeah, exclusive.
Sorry, I just meant to add a little thing to what that bro said. In order not just to confuse everything, I think an array is already a pointer on its own. So the array is already a pointer. We don't need to add a pointer. So if you try to look for the address of the array, you will see that the address of the array is same as the address of the first value in that array. So it's not like the array is pointing to the whole figures inside the blocks. It's just that it's pointing to that first number of the block. So it's already an array. So since it's already a pointer and it's pointed to that 10, we don't need to add another extra pointer to it. So that's just what I want to say. So.
Okay, thank you so much. That made a whole lot of sense. All right. Any other question? Do we have more questions in the house? Okay, Joshua.
Hello.
Hello.
I really appreciate the lecture. Please, I want to explain this number 12. Print F, percentage D, the pointer. I don't understand that one, please. I want to be clear. It's like the output. It does not print that output.
Okay. All right. Thank you so much. All right. So the %D is referring to what the pointer is pointing to for that iteration. So remember, our for loop is going from the first element to the second element and all the way, right? So for each time it goes to each of them, it produces an output. So the first time it goes, it produces 10. And remember, we said when we put an asterisk before a pointer, it is pointing to the value. It refers to the value in the address that the pointer is pointing to, right? So the pointer is pointing to array, and then the first element is 10. So when it iterates at when it uses the first initialization, when it goes round, it would when it checks the condition, it will print the first element, which is the 0 element, right? Do you understand me, Mr. Joshua? Do you understand me?
Or, yes. I'm getting you.
Further. Okay. So when it goes for the 0 element, it will print it. So this asterisk before pointer means instead of the address, it is pointing the value. It is printing the value. So we're printing the value for each of them. And that is why we have these outputs here.
Thank you.
All right, thank you. Then we have Justice Obasi raising his hands.
Yeah, I have a question on line 7 and line 13.
Okay.
I don't really understand what's happened on that line 7. You said the size of the array divided by any of the elements in the array. Does it mean is it the 10, the value in that first element, that element 0, is it that 10 that divided the size of the array, or what? I don't really understand that aspect. What is being divided actually?
Okay. Now, when we say size of an array, right?
Yeah.
When we refer to size of an array, how many elements are in this array?
5.
There are 5, right?
Yeah.
So that is the size of the array. Do you understand?
Okay. So are you saying 5 divided
by
10?
one element? By any element. Even if you decide to put 3. Okay, let's put 3 in that. Let's put 3 here. It will still give us the same thing. Do you understand?
No.
Hello.
Did you get that?
I don't understand it. If the
it's just
3
like
you
saying
put
5
now.
divided.
Hello, Mr. Justice.
Yeah.
Yeah.
Can you hear me?
I can hear you.
We can hear you, Dixon. Hello.
Hello.
Yeah.
Yeah,
I can
we
hear
can
you.
hear you now.
Okay. Hello. Hello.
We can hear you.
Hi, Dixon. We can hear you.
Okay. See. Okay. Okay. Mr. Justice. See. Okay, Mr. Justice.
Yes, I'm hearing you.
Yeah, I'm speaking now.
Yes, I'm hearing you. Go ahead.
This is what's happening. You know, you're declaring an array and you're saying it's an integer. It's an integer, and by default, you know an integer has a size of 4 bytes.
Yes.
Okay.
An array has an integer has a size of 4 bytes.
Yes.
Okay, now you're declaring an array and you're saying that you want to create an array with 5 elements in it. So now, what it's going to do is going to keep 5 times the number of elements. If you understand, like now, for instance, you have 4 bytes for 1 element.
Okay.
As an integer data type.
Okay.
So you're keeping 5. So that will be 20 blocks that will be kept for the array.
Yes, I think.
But now I want to know.
Okay.
Okay, let me continue from where you stopped.
The size of that particular array. So now it will now be the full block of memory that has been assigned divided by
1 block.
Okay, I don't know. You wanted to explain for Abby?
Okay, you were breaking your line. Your communication was breaking, so that was why I wanted to chip in. Yes. Can you hear me? So this is what I'm saying, right? It's 4 times 5, which is 20, then divided by the size of one of the blocks, right? Which is 4. So 20 divided by 4. But, I don't know, the one way that helps me really understand it was because I know it's already 4 times 5, which when you divide is still 5. So I just take it as 5 elements divided by 1, which will still give you 5.
Yeah, I understand you.
Do you understand?
I understand it now. Yes.
So that's like a shortcut for me.
Yes.
But I think he's just painting a clearer picture, which is for each element there is 4 bytes because the size of an integer is 4. So for each of them, so we have 4 times 5, which is 20. Then when we divide the portion of 1,
yes,
that is 4. It will give us 5.
Yeah, I understand that.
Yes.
Okay, so
yes,
on
so that's basically
line 13.
Then third line
13.
Line 13.
Yes.
Okay.
I remember earlier when you were explaining how to print out the value of a variable and the pointer. Without putting the asterisk, you print out the value, or the asterisk refers to the value where of the variable of the pointer, or where the pointer is pointing to.
Yeah.
Now on display you say the pointer plus plus without putting the arrow. What is it not printing the address, or what is it about? I don't understand that.
If you notice, there's no printf for that part we're adding, that we're incrementing.
Yes.
Right? So it means after you've printed what is in the first element, it means you go to the next element. This plus plus is simply saying move to the next address.
Okay.
Do you understand?
Okay.
So just as this one has incremented I to become 1, this one has also moved the pointer to the next address. Do you understand?
Yes.
So when we go with 1, it will now be element 1, right?
Yes.
Then the pointer will now push it again to the next address.
Okay.
I don't know if that's clear.
Yeah, and the printf will not print out the value there. Okay, I think that makes sense.
Yes.
That makes sense.
When because we don't want only the index to increase, we also want the address we want it to move to the next address. So if we don't increment the pointer, if we don't ask it to move to the next address, it would probably just print this. Let's try it and see. Let's see what will happen if we don't increment. You can see that it's printing 10, 10, 10, 10, 10.
Okay, yeah.
Yes. But that's why we need to take it to the next address.
Yes.
Yes, so that is the role that this part plays. Sorry.
Okay. Thank you. I understand it.
Is that clear?
Thank you. Yes, thank you.
Okay. Is there any other question? Okay, I guess that is all for today. But then I have some questions just to engage us, to be sure that we have gotten the whole concept, right? So I have some questions. I don't know if we're ready to answer. I hope we're ready to answer. Okay, so I'll be posting each of them on when I post it on the the chat box, or let me just simply read it. So the first one, just to be sure that we have gained something from the class. Do we have people here?
Yes.
Hello, can you hear me?
People.
Okay. So what is the purpose of pointers in C programming?
Hello?
Hello, I can hear you.
Pointer is used to store an address of a variable.
Okay, beautiful.
Secondly, it's help to manage the memory.
Okay.
It helps to manage memory.
Yes.
Thank you.
Thank you so much. Well done. That's a good one. Okay, so the next question is, what is the difference between pointer and a regular variable in C programming language? Do we have anybody who wants to answer
the question
that?
again.
The second question is, what is the
again,
difference? Okay, what is the difference between a pointer and a regular variable in C programming language? Just in case you didn't hear me clearly, I posted it on the chat box.
I think the difference is the pointer store an address.
Okay.
Of the store address of variable.
Yes,
Hello?
yes, I can hear you.
Yes. Why variable just store a value?
Okay, beautiful.
Variable
Well done,
just store
sir.
a value. Thank you, sir. Thank you, ma'am.
Well done. Any other person wants to add to that? Yes, or is Sarah?
Like what we were saying before, a normal variable.
Like you said
Okay,
earlier,
yeah.
a pointer is a variable with superpowers. Like it can access the address. It can store the address of a regular variable. It can also point to the value, or it can retrieve the value of the value stored in the address of a variable, or something like that.
Okay, beautiful. Well done. That's good. Mr. Dixon, you wanted to say something?
I was saying that that the major power behind pointers is that you can use it for calling by reference, as in whereby you can manipulate a memory location and modify whatever is in that location. But a normal variable would just only access that memory location without having that power to modify. Thank you.
Okay, beautiful. Thank you so much, Dixon. Okay, so next question. Next question is, how do you declare a pointer in C programming language? How do you declare a pointer in C programming language? Anybody willing to answer that question?
Hello. To declare a pointer in C, first of all, you declare the data type and then asterisk followed by the pointer name.
Okay, beautiful. Well done. Well done, Wilfred. Then we have another question. How do you access the value stored at the memory address pointed by a pointer? How do you, let me post it here. Okay, so how do you declare a point? Oh, sorry, I repeated the same question. Let me go back and get my question. How do you access the value stored in the memory address? The value stored in the memory address. How do you access it using a pointer?
Make use of the asterisk sign.
Okay, beautiful. Beautiful. So you make use of the asterisk sign. That means we have specialists here. Awesome. Okay. All right. I think we'll stop here for today. Any other questions? Any other questions about pointers? Do we have any more questions about pointers? Okay, if there is none, then I would say we have come to the end of today's session. Thank you so much for having me, and thank you for not throwing very, very, very difficult questions at me. And thank you to those who saved me when the questions were being thrown. All right, so I think it's time for us to unmute and say bye to each other.
I want to be like you, to be very good. I want to be like you, to be very good.
You really tried.
Oh, thank you.
Thank
you so much.
Bye-bye.
You said?
I said you're a very good teacher.
Oh, thank you. Thank you so much. Have a lovely night, everyone. Good night.
Good night, everyone.
Good night, everyone.
Bye.
If you are teaching in nursery and primary school.
Who dey yawn?